Hello to everyone who's watching the video. My name is Arata, and I am going to be talking about my senior capstone, which is improving generalizability of multimodal sentiment analysis. So, sentiment analysis is a very well-known field in natural language processing that deals with predicting sentiment from a textual data. Right, so whether if that text has a positive connotation or a negative connotation, it's happy or sad, those kind of stuff. And what's different with multimodal sentiment analysis is that it not only uses textual data to analyze that sentiment, but also acoustic data and visual data. So it uses these three data modalities to kind of have a holistic understanding of what the speaker in the video is conveying. And MSA model is a relatively new field, and it has very limited amount of data set. It has small data sets. And that's why generalizability of MSA is really important, because we need to establish a way of leveraging that every bit of small details in that limited amount of data set to be able to build a MSA model that can not only predict sentiment in a very small amount of data, but in a wide range of data. And so my approach to that is combining two state-of-the-art models, which is tensor fusion network and select additive learning. So tensor fusion network, or TFN, models not only the intra-modality, but also the intermodality dynamics, which is the relationship between different data modalities. And furthermore, select additive learning identifies and removes confounding factors. And confounding factors can be described as a combination of data that coincidentally misleads machine learning models into learning something that it should not. And by not removing these confounding factors, MSA models can give misleading predictions. So this is my data architecture diagram. As you can see, I am using two different data sets for cross-validation to test the generalizability of my model. CMU MOSAIC dataset, the training dataset, has already the three modalities that are extracted from the video, and I use different feature extractors to extract the features of each modality, and I pass it into the tensor fusion network. And that tensor fusion network returns the tensor that are merged, and I pass it into the south CNN, and then I validate that using the mode data set, and then I get the sentiment scores. And as we can all see, results suggest that my model generalizes better than the previous models. All jokes aside, I'm working on it, and I am going to get the results done.